Okay, this is a video for some guided practice in forces in motion for AQA physics. This is good for combined science and for triple, for foundation students and for higher students. Okay, now we're going to be looking at fixing some mistakes that are really common in answering some exam questions based on forces in motion. You can find the exam questions at the link at the top or using the QR code. Okay. Now, first thing I just want to point out is the equation sheet that we'll be getting in 2023. Now, next year won't get all the equation sheets that you're going to be getting. Okay, so you should take advantage of it. This one is the Triple for Science equation sheet. It's very similar to the other ones, it's just got a few extra equations. It is split up into topics. So the first topic is energy, the next topic is electricity, then we've got particles, and we've got a big topic on forces, and this is what we're going to be using today, and we have waves and we have electromagnetism. Use this equation, have it next to you all the time when answering questions. When you come to a question, think about what topic is this focused on. Is this a forces question? Is this a waves question? Okay, and be ready to go to the right section of the equation sheet to help you answer the questions. Okay, now the way this video is going to work, we're going to have different coloured slides. The red ones is when you're listening, you're reading, and you're not talking, and you're focused on what's happening on the screen. Okay, you're finding mistakes for the most part. The green slides, that's where you're going to be pausing and you're going to be doing. You're reflecting, you're writing, and you're fixing mistakes. Okay, the majority of the time is going to be independent work. It's going to be you doing the work. Okay, I will guide you through questions and then you're going to make them better. You're going to fix stuff. Okay, so we've got a bunch of questions and then you've got some time. If you have, you can go through it yourselves. Now, in order to do this, you're going to need something to write on. So it can be a piece of paper, a scrapbook of paper, the back of your exercise book, the front of your exercise book if you want to do it nice and neatly, or a whiteboard, something that you can write on and interact with. Okay, that's the only thing you will need. Okay, so first question. First question is on terminal velocity. Now, when you look at this, we wouldn't initially think terminal velocity because there's no parachutes. Okay, terminal velocity doesn't have to be about parachuting. Okay, it's anything that's dropping through some kind of fluid. And when I say fluid, I mean something that's either a liquid or a gas. Both are fluids. Okay, and in this case, the fluid we're dropping through is oil. So we've got some modelling clay that's going through a measuring cylinder filled with oil, and we're looking at how quickly it takes to drop through this measuring cylinder. Okay, and we've got a bunch of questions that are answered here, and some of it is wrong. Your job is to find the mistakes. Okay, where are they getting marks? Where are they losing marks? So we've got this first one. We need to say, what is the distance fallen by the modelled clay? Okay, the ticked answer is A to D. Then we say, what is the measuring instrument used to measure the distance fallen? What piece of equipment? And we've got a meter ruler. And then we've got 4 different pieces of modelling clay. Each have a different shape. Okay, and each piece of the student is dropped, and we see the time it takes to fall through the distance. And then question C says the student removed each piece of modelling clay from the oil before dropping the next piece. It's just one reason why. If too many bits of clay had stayed inside the oil, it will make it spill out the top. And that's what the answer they've given us. Will that get any marks? Then we've got a table where we've got the different shapes. So we've got a sphere, a cube, a cylinder, and a cone. We've got the time taken in seconds for it to drop, and they've done it 3 times. They've done drop 1, drop 2, drop 3, and then we've got a mean column. Okay, and we've got the whole results filled out for the sphere, for the cube, and for the cone, but not the cylinder. And we need to find that missing value. We need to find that missing mean. Okay, and this is how the students done it. They've done 34 plus 37 plus 34 divided by 3 to give 82.3. Okay, so what I want you to do, I want you to pause the video and I want you to see where you can fix the mistakes and where they have marks already. Okay, so pause the video now. Okay, moving on. Now, this student will get some marks for these questions. Okay, they don't have any marks for question A or question C, and they have dropped a mark for question D. So here, this sphere is dropping through the oil. If we go from the top of the sphere at A to D, that's not the height that the sphere has dropped through. It's not the height the modelling clay has dropped through. It's the height plus some height of the actual modelling clay. It's not the distance that it's dropped through. Okay, that distance would be, okay, moving on, would be B to D. Now they've got the mark for meter ruler, that's fine. You can also say a tape measure, okay? But the reason, while it's true that if there were lots of bits of clay inside it, it would make it spill at the top, that's not why they do it. It's not to stop making a mess. If we left all the bits of clay at the bottom, the height would be different each time, and the height is a control variable. Lots of the time these suggest why they've done it is because of control variables. You need to figure out that in this case, the height that the modelling clay drops through is the most important control variable. If it's a different height every time, of course it will take a different amount of time to drop. Okay, so each piece falls by the same distance every time. Okay, stops them building up at the bottom. Now, the last question is a really common mistake that students would make. Okay, because they get a mark for their sum, for their calculation here, they get this first mark, because that's correct. 34 plus 37 plus 34 divided by 3, that's right. Okay, the problem is how they're using the calculator. Okay, because the answer is not 82, of course it's not 82. Okay, so then how do they do it wrong? What's going on? Okay, well here's two calculators. Here's the first way we can put it in, 34 plus 37 plus 34, just as written down, divided by 3, and we get 82.333. Okay, now this is wrong because we haven't used brackets. What we've actually done is add 34 to 37, and then we've added a third of 34 to that, and that gives us 82.3. Okay, we need to be really careful when we do this type of calculation that we either find out that total first and then divide the total by 3, or put it in brackets. I prefer to put it in brackets. I think that gives you a better answer. Okay, the second thing you need to be aware of is that you need to give your answers in decimal form. You can't give them in fractions. Now these calculators, not your calculators, a lot of the time by default will give you a fraction. And if you write down the fraction of the answer, you won't get marks. Okay, so you need to either change the settings of it or be ready to use the SD button to change from a fraction to a decimal. Okay, so we get the answer. So the answer is 35. Now, if you got 82 as your answer, you want to make sure, okay, that it makes sense. Do a sanity check, as I call it. Okay, 82 is bigger than the biggest value in that row. Okay, so it's got to be wrong. If it's bigger than the biggest value or smaller than the smallest value for the mean, it's wrong. It's got to be between the biggest, which is 37, and 34, the smallest. It's got to be between those two numbers. So 35 is bigger than the lowest one, smaller than the biggest one. It makes sense. Okay, so do a sanity check. Make sure your answer makes sense. Okay, moving on. Next question. We've got, still about this modelling clay dropping through the oil. We've got each piece has the same mass. Okay, and we've got which shape of the table above had the smallest resistive force acting against it as it fell. Was it the cone, the cube, the cylinder, or the sphere, and why? The surface area is the smallest, okay, is the answer they put. How will the time taken for the fall to change if the modelling clay was dropped through the air? Would it take less time? Would it take more time? Would it be the same? And then we've got a calculation question where we're given the mass, we're given the gravitational field strength, we're given the equation, weight equals mass times gravitational field strength, and we need to work out what the weight is. Okay, so pause the video and see how many marks that you think they should get and how you would correct them if you think they need to be corrected. Okay, right, we're going to move on. Now this first question, really common way you can answer this question is this, but it doesn't get the marks. You get the right answer, cone, but we've not written the reason. So we've written the surface area is smallest. That might well be true, but that's not the answer to the question it's asking. Which shape in the table had the smallest resistive force acting against it, and the reason why we picked it. The reason why we know it's the cone is because it had the shortest time. Okay, the mean time for the cone was the smallest. Now it might well be because the surface area is the smallest, cause it to have the shortest amount of time, because it was more streamlined, but that's not the answer that we're looking for. We're looking at why you know it's the cone. Okay, and that's to do with the time taken. Okay, next bit, air is true because it would go through less because air's much less viscous, it's much less thick than oil, so there's less resistive forces that have a higher terminal velocity. Okay, last question, this is incorrect. Okay, really common mistake again, especially if you're in a stressed exam situation. We've got these numbers, we write it down. This is called a transcription error, where you can see the number here and we've just lost the 0 after the decimal point. Okay, and in this case we drop both marks because of it. We've lost the mark for substitution and we've lost the mark for the answer. Okay, AQA are quite harsh in the way they model these. So this is the right answers. We've got the mark for the cone. We get the next mark for the mean time was the lowest for the cone, so we get 2 marks for this now. And we still have the mark for the air, but this one, put in the right numbers and we get 0.49 newtons. Okay, right, moving on. Now this question is about the required practical for forces. Okay, one of the required practicals, the ones on Newton's laws. It's the hardest of, I think, all of the required practicals in physics. It's tough, it's confusing, there's lots of ways it can be examined. Okay, there's lots of ways you can do the experiment. You don't have to have this sort of setup. You can have different setups. You can have different forces pushing the trolley. You could use springs. You could just use slopes. You can use all sorts of different ways of measuring acceleration. There's lots and lots of different ways of doing it, which makes it more complicated to answer the questions. Okay, so one of the things that you need to be aware of is when you see a setup like this, you need to think, what is each piece that's labelled, which piece in the diagram, what's its job? Okay, why is there a card on top of the trolley? Okay, what does the light gate do? What's the data logger? Now in this case, the card goes through the light gate, which allows it to measure the acceleration, which is logged by the data logger, so you can write it down in your table. The mass holder here is what's pulling the car down. So the mass has weight. It's causing the force of weight to act on this trolley that pulls it along the table. Okay, the wooden block is there, okay, as a way of counteracting the frictional forces in the wheels. Okay, if you set it up properly, you can get the slope so the car is just on the cusp of moving and will start to accelerate if we put some mass on this holder. Okay, if friction was really big, it's nice to think about it was really big, you'd need a much bigger force here to even start it to accelerate because the frictional forces are so large. We want to try and remove those as much as possible. That would be a control variable. Okay, now, question is, before attaching the mass holder, the student placed the trolley at the top of the runway. The trolley rolled down the runway without being pushed. What change to the apparatus in the diagram could be made to prevent the trolley from starting to roll down the runway? Okay, so it's thinking about this wooden block. Move the wooden block to the left, shorten the length of the runway, use a taller wooden block. Okay, so what would be the right change? Then it says the student attached the mass holder to the string, down here. The string rubbed along the edge of the bench as the mass holder fell to the floor. What could the student do to prevent the string from rubbing? And the answer is put some oil at the edge of the table to make it slide better. Okay, so can you improve these answers? How many marks do you think they've got? Now, there's only 2 marks, so you shouldn't take too long on this. Okay, so pause the video here. Okay, moving on. Now, they've got the first mark. You do need to move the wooden block to the left. It will lower the slant of the sloping runway, which will allow less of that weight to be pushing it down the runway, so it won't start running away. Okay, so move the block to the left is correct. But this one, put some oil at the surface of the edge, that is going to help the problems. It will reduce friction, but it's still going to be running along the edge of the table and it will make a terrible set of results. So instead of that, you need to put in some kind of pulley system. So it's easier for this downward force, this weight from the mass holder, to pull on the trolley. Okay, so add a pulley. Okay, add a pulley to the edge of the table. Okay, moving on. We have a set of results. Okay, so the light gate and the data logger were used to determine the acceleration of the trolley. The student increased the resultant force acting on the trolley and recorded the acceleration of the trolley. Then we've got the results here. We've got resultant force in newtons and we've got acceleration in meters per second. Okay, and the question for 4 marks says, complete the graph. And we have this graph paper that was given. We were given the acceleration scale. We weren't given the resultant force scale. And we need to choose a suitable scale for the x-axis. So the resultant force in newtons. We need to plot the results and we need to draw a line of best fit. Okay, so what I want you to do, I want you to point out, I want you to write down what are the mistakes in this graph. What did the student do, or what did I do, that means that they're not getting marks. How would you do it better? Okay, so pause the video here. Okay, moving on. Now, they don't get any marks for this graph. This graph is terrible. Okay, so the first thing, the scale. Okay, they've got it's a good job of a scale. Okay, because we've got the right numbers in the right in places, but it's not consistent. Okay, it's 10 squares, 10 little squares between 0.05 and 0.1, but it's only 5 squares between 0 and 0.05. So the scale isn't consistent, so we lose the mark for the scale. Now there are 2 marks in this question for the plotting of the results, and we don't get any of them. And you might look at this and you think, well, that dot is in the right spot. Okay, this dot is in the right spot. But, okay, AQA will give you a leeway of half of a square. So if you get the spot, the data point wrong by less than half a square, you get given the benefit of the doubt and you get the mark. Okay? Each of these spots, each of these dots that I've drawn is bigger than half of a square wide. Okay, this one at the bottom is nearly 2 squares wide. So even if it's in the right spot, and I have tried to put the centre in the right spot, I don't get the mark. Okay, the examiner can't be sure about where the centre of this circle is, and they won't give you the benefit. Okay, so none of these points will get the mark. You need to draw crosses. The next point is the line of best fit. Now, you still could have got the mark for the line of best fit for the trend, but in this case, I had used a really small ruler. I used my ID card. Okay, so this first part of the graph here, sorry, the end of the part of the graph here, it is a pretty straight line, but then it goes a little bit wobbly, and that wobble is enough for me to lose the mark. Okay, now if I'd done this in pencil, I could have corrected it, but I did it in pen, so it's fixed. So in your exam, you need to have a sharp pencil and a sharpener in case your pencil stops being sharp. So here's a much better graph. I've got a good scale. It's consistent. The distance between each of my points is the same. Okay? I've got the points plotted with little crosses. That's correct. All of the points are in the right spots. Okay, and you'll even notice, because it was in pencil, very faintly, which I have rubbed out, the first cross I put was in the wrong spot. I had to rub it out and put it in the correct spot. Okay, that's the benefit of using a pencil. Okay, and finally, the line of best fit is drawn beautifully with a ruler. Now, when you're drawing a line of best fit, the important thing is it fits the pattern. And in this case, it is a straight line. It does not have to be a straight line. It could be a curved line. Okay, so long as it fits the pattern, okay, that's the key. Doesn't have to be with a ruler, okay, if it's a curve. Now, in this case, the graph is a straight line. This straight line fits the pattern really well, so it should be drawn with a ruler. Okay, but if it's a curved line, if it's a different relationship to this one, you should draw it as a curve. Right, moving on. Next question. We need to describe the relationship between the acceleration and the force. Okay, so the answer here is there is a positive correlation. Then we need to describe how the investigation could be improved to reduce the effect of random errors. Okay, and they've said repeat the experiment 5 times and find the mean for each weight pulling the trolley. Okay, so I want you to correct, I want you to fix the mistakes that are there if there are any. Okay, moving on. So this question, writing the answer like this is a really common thing to do, and it's really frustrating for the students who write these answers because it's true. What they've written is correct, but they haven't been able to get all the marks. Okay, so it is true, there is a positive correlation. As the resultant force goes up, acceleration goes up, but that's not the only thing about the relationship. That doesn't tell me that it's a straight line. Okay, it could be a curvy line, it could be a wonky line, so long as the acceleration and the resultant force are going up, it is a positive correlation. Okay, you need to say a specific relationship. Okay, it needs to be directly proportional. Okay, the next question is even more frustrating, I think. Repeat the experiment 5 times and find the mean. That gets the first mark. Okay, sorry, the repeat the experiment 5 times gets the mark. But just finding the mean isn't enough to reduce the effect of random errors. You also need to remove anomalies. Okay, so for this, when you say directly proportional, it's a straight line that goes through 0. Okay, that phrase directly proportional is really important for you to know. It's crucial. That comes up so often in your physics papers. And even when it doesn't come up, when it's a curved line, okay, when it's going negative, when it's some other kind of shape, saying it's not directly proportional will often get you a mark. Okay, so you really need to be able to be aware of that. And especially if a straight line goes through 0, immediately think directly proportional. The next bit, you have to say the remove. If you don't say the remove, random errors are still going to decrease they're still going to have a big impact on the experiment. Okay, so by removing the data points that are obviously not fitting the pattern. So if, for instance, I'd done this a whole bunch of times, and at point 1 I had an acceleration of 2.5 meters per second, which isn't even on the scale here, that's obviously not fitting the pattern. Something's gone wrong with my result. I'll ignore that point. Okay, I might repeat it, okay, but I won't use it in my meet because it doesn't fit the pattern. Okay, right, moving on. Calculation question. We need to write down the equation that links acceleration, mass, and resultant force. And we've got mass times resultant force. We've got the resultant force on the trolley is 0.375 newtons. The mass of the trolley is 0.6 kilograms. We need to calculate the acceleration of the trolley. And we need to give our answer to two significant figures. And here is our calculation, and here is our answer. Okay, so your job, you need to find and you need to fix the mistake. Okay, so pause the video here. Okay, moving on. Now this one, okay, this is not an equation. An equation has to have an equal sign. Okay, these questions will come up in your GCSE, and where should you go immediately? You should go to your equation sheet. It's a matter of finding acceleration, mass, and resultant force on your equation sheet and writing down the equation. Okay, there will only be one equation that has the three things that it's asking you about. Okay, and if you haven't written all three things down, you're not going to get the marks. Okay, this one's missing force. Just by putting force equals mass times resultant force would get you the mark. Now here, okay, here we've not substituted properly. Okay, this might be a student who's stressed to come to the end of their time and they're rushing a little bit. So they're not putting down their work in a logical order. They're not doing the steps that will get the marks. What they have done that's fantastic, they still have a mark at the end. Even though this calculation is wrong, they get a mark for putting their answer to two significant figures. They've used the numbers in the question, they've rounded it to two significant figures correctly, and they get that error carried forward mark. Okay, so they still get 1, but they need to be able to get 4. Okay, now the way you do this, so we put in our equation, force equals mass times resultant force. I like to circle or highlight the data I'm given, and sometimes I'll even draw arrows. I'll link it to the equation. Now it's really often, every question that I've seen so far that AQ have produced, when they say write down the equation that links whatever the things are, they will immediately get you to use that equation. Okay, I've not seen it where they haven't done that. They might throw a curveball in there and do something weird, but it's really, 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 really common that they ask for an equation, then they get you to use it. Okay, now the way I've set this out means it's less likely to make a mistake. Okay, you're less likely to make a mistake when you set it out like this. The first thing you notice, hopefully, my equal sign always slides up. It lines up there down the middle of the words here, of the lines. Okay, easy to follow. Makes the examiner's job a bit easier to give you the marks. So the first thing we do, we write the equation down. I know you've already written it down up here, but write it down again. Write it down, then we substitute. We don't rearrange first, we substitute first. So force equals mass times acceleration. We put the force in here, 0.375 newtons. We then substitute in the mass for 0.60, and then we times it by A. We don't know what A is, that's the acceleration. Then I rearrange. Okay, now you can use the equation triangles to do if you wish. Okay, or you can think back to maths and think, okay, what's the inverse of timesing by 0.6? The inverse is the opposite, which is be a divide. So we do 0.375 divided by 0.6 to give me acceleration. Okay, I write down the answer from my calculator, then I will change it into two significant figures and I get my 4 marks. Now 5 marks isn't that far away from a grade boundary. Okay, depending on the year of the paper, depending on which grade boundary it is, it could be 8, 9, 10 marks of a grade boundary, maybe a little bit smaller sometimes. Okay, so it's important that you can get these marks and you do it by following those steps all the time. Okay, right, next question. I'm not 100% sure if you'll be able to see the graph when I put up the question next to it. So if you can take a screenshot of this, or you can go back to it if you need to actually use the graph. Okay, so the question is on velocity time graphs. Okay, it's a car driving along a straight road. Okay, we've got velocity in meters per second and we've got time in seconds, and we've got this graph split up into 4 sections. Okay, now immediately if I see a graph like this, okay, I will highlight the word velocity. It's really common that students mix up velocity time graphs and distance time graphs, and they are different. Okay, a straight line, a horizontal line in a velocity time graph is different to a straight line in a distance time graph. They are different. And just try and maybe highlight or circle just to remind yourself when you're doing the question that they are different. Okay, so here's the question. We've got from B to C, the car is moving at a constant velocity, and we need to complete the sentence. From B to C, the driving force is something, it might be less than, the backward resistance forces. This question, as a bit of a hint, is about the first law of motion, Newton's first law. Then, from C to D, the car is slowing down. What word is used to describe the motion of an object that is slowing down? Braking is what they put. Between A and B, the car is accelerating. Calculate the acceleration of the car between A and B. Use the equation. Okay, and we've been given the equation in this question. Acceleration equals change in velocity divided by time taken. We've taken some numbers from figure 1 and we've put them into this thing. We've got a number and that's where we're at. Okay, so I want you to try and figure out where the mistakes are, how you can correct them. Okay, pause the video here. Okay, moving on. So, didn't get any marks, I'm afraid. None of this is correct. Well, none of this is good enough to get marks. So for this first question, if it's moving at a constant velocity, the acceleration is 0. If the acceleration is 0, Newton's first law of motion tells me that there will be no resultant force. Okay, now there are two forces acting here. There's the forwards driving force and the backwards resistive force. If there's no resultant force, they've got to be the same. They've got to be equal to each other. Okay, so knowing how to apply that first law is really important for this question. Now, for C to D, okay, the car is slowing down. While you might think it's braking, and this question is related to braking, okay, that's not what we call it. We call it deceleration. So to get the mark, we need to put deceleration. Finally, they got the wrong numbers in the graph. This isn't 16. 16 would be down here. Okay, much lower than about that point B. So they didn't get the right. They didn't get the right points, and they substituted it upside down. Okay, so to get the points, we need to do 18 divided by 6 to get 3 meters per second. Okay, so be really careful when you're taking these numbers from here that it doesn't confuse you when you're then substituting them in. Okay, it's good practice to draw on the graph to show where the numbers are. You might get credit for that depending on the question. Now, next, final question before you go off and do your own work. We've got this other graph. It's related to this first question about stopping and braking and reducing the speed. Here we've got this graph of stopping distance in meters and speed in meters per second. And the question says, describe what happens to the stopping distance of the car when the speed of the car doubles. So what happens to the stopping distance when the speed doubles? And the answer they put is, the stopping distance is getting bigger and bigger. Okay, so is that a really good answer? Is that worth 2 marks? Is it worth 1 mark? Is it worth no marks? How would you improve it? Okay, pause the video here. Okay, moving on. They get 1 mark because the stopping distance does get bigger. It increases. Okay, but the key is it's not a straight line. It's not directly proportional. Okay, so it gets bigger than double. When you double the speed, you more than double the distance in meters. Okay, stopping distance is increasing by more than double. That gets both points. Okay, right, now on the link at the top here and on the QR code, there's a link to the first 3 questions, which we've just gone through, and 3 other new questions. Okay, so give these questions 4, 5, and 6, if we've got enough time, a go. Mark them after you've given them the go. See where you're getting the marks. See if similar things turn up. Okay? Okay, well done. I hope this was useful. Thanks very much. Toodaloo.